Algebra 2, Lesson 3.5, page 124. Today we're going to talk about systems of linear equations in two variables. Open up your textbooks and look at page 124, and this will help you to understand the different things I'm going to talk with you about as we go through this lesson. Rather than write crazy notes, I'm going to talk through what's actually in the book. So look with me at your book, please, and we'll go from there. So they've got several bolded words here. A linear equation, a set, which means a pair. So a set, you could even have multiple equations, but for our purposes, we're going to call a set two. Two linear equations, so x and y, is a system. Okay, usually I'll just refer to it as a system, and this is what I'm referring to here. Okay, whenever you find a solution to both lines, that is called a solution. I don't use this simultaneous solution word, but you might see it in other applications. For example, x minus 2y is 5, and 4x minus 3y is 9. If I graph x minus 2y is 5, I have this. If I graph 4x plus 3y is 9, I have the other line. That being said, these 2 points intersect at 3, negative 1, which would make 3, negative 1 a solution to this set of systems. Okay? I have two lines here. I have x plus 2y equals 8, and I also have y equals negative 1/2 x plus 4. So what they did here is they simply wrote it in two different ways. They wrote it ax plus by equals c, whereas this other equation, this other line, they wrote y equals mx plus b form. So this is actually this line, and the y equals is the top line after they translated it to that form. Now, strangely enough, you might not realize, but these two equations actually graph the same line, and you can test that for yourself. So that would mean whatever points are along this line are solutions to both equations. Okay? Now, they share the relationships here, and it's important to note that if they intersect, they will have one solution. It's important to note that if they are parallel, they never touch. That would mean that the system has no solution. And finally, if they coincide, which means they are one on top of the other, then every ordered pair that satisfies one will also satisfy the other. So there are infinitely solution sets that fall upon that line. Okay? Now, equivalent systems are systems that have the same solution set. Now, I'm going to go a little bit further into that here once we get started, but I want to take your attention over to the top of the next page as I share this with you. There are three separate models for how to solve these. Okay, and I know you can read this yourself, but just in case you're at home and you don't have your book handy, we can replace an equation with an equivalent equation. All right? In other words, 2/4 times 4/4 is 4/8. That's the same thing. All we've done is change the values. And they write that in parentheses. If you multiply both sides of an equation by the same number, you still have an equivalent equation. Perhaps substituting one variable in an equation for another variable. And I'll explain this to you, okay? But all of this is what we're going to be talking about here. And finally, replacing any equation by the sum of that equation and another one, okay? Bear with me here, and we're going to go through all this as I start with example 1, okay? So, example 1. As we do systems of linear equations, here we go. The first one, solve this system. This is example 1, and we are now on page 125. 4x plus 3y equals 5. And they also have 2x minus 5y equals negative 17. Okay? And I'm going to write that off to the side. 2x minus 5 y equals negative 17. Now the technique I am about to show you, it's a little bit strange, but I promise you, you will understand it. Okay, do you guys see the second equation right here? That's this one right here. If I take this second equation and multiply the entire thing by a negative 2, I will have negative 2x minus 10y equals positive 34. Okay? Now, the reason I did that is I was looking for I'm sorry, that should be a 4, Mrs. Myers. I was looking for a match and opposite of something within the first equation. I chose to go with that because I knew that 2 times negative 2 would produce that, which is the opposite of that. Now here's why. I am going to take this equation and add it to the original. Remember, this is the same as this, okay? I am going to add negative 4x minus 10y equals 34. Okay, this process that we're doing, adding these equations together, I will be able to solve the equation. Okay, I'll be able to solve it. Now, this is called the linear combination method. All right, and they actually discuss that on the next page, which bothers me. But this is the linear combination method. Now, notice 4x and negative 4x cancels themselves out. Gives us negative 7y, oops, that's positive. That became positive. A negative times a negative became a positive. Good grief. 13y equals 39. Okay? Divide, and I have just found that y equals what? 3. Okay, so if y equals 3, then I could substitute into either one of these equations to solve for x. I'm going to do it in that one. 4x plus 9 equals 5. 3 times 3, right? 4x plus 9 equals 5. Subtract 9 from both sides, and you get 4x equals negative 4. Dividing, and you get x equals negative 1. Therefore, the solution is negative 1, 3. Negative 1 being the x value, 3 being the y value. As mentioned previously, this is called the linear combination method. Okay, this video is going to have multiple parts, so bear with me. This is the linear combination method. Okay? Go ahead and turn the page with me to page 126. They give us another system here, and they are going to have us use the linear combination method first, but then they're going to teach us a new technique. Okay? So here we are. We've just learned the linear combination method. I'm going to go ahead and start with solution 1. Okay? So this is example 2. Still using the linear combination method. Okay? So, example 2. Solve this system. X minus 2y equals 5. The other one is 4x plus 3y equals 9. Now, I don't really want to mess with the y's because I would have to multiply this by a 3 and this by a 2 to create a negative 6 and a positive 6, thereby canceling out my y's. Remember, my goal is to create a coefficient of either x or y that would cancel out the other coefficient, the other variable, so that you're only left with, well, like in this one, we were only left with y. I am going to multiply the first equation by negative 4. When I do that, that will allow me to have only negative 4x, positive 8y, negative 20. Notice the x's are going to cancel themselves out here because I took the result of this multiplication, plugged it in here, and now we are going to combine the two linear equations. These guys cancel out. 11y equals negative 11. Therefore, y equals negative 1. I'm not done though, people. Remember, my solution has to include an x and a y, and I already have my y. So I am going to use my y. I'm going to plug it into either this equation or that equation in order to find out what x is. And I am actually going to plug it in to this early equation here. So it's going to be a negative 2 times a negative 1, which gives me a positive 2. X plus 2. That's the result of negative 2 times negative 1 equals 5. Subtract 2. Looks like I have x equaling 3. And if you verify in the textbook, 3, negative 1 indeed is the correct solution to this linear system. Okay? That is the correct solution to this linear system. All right? There is another way to solve these, which can be very, very handy when a coefficient is a 1, like in this one. And that is actually called the substitution method. Okay, so we're going to talk about the substitution method next, but recognize there are two methods, linear combo and substitution, which I am about to share with you. The substitution method involves solving for one variable and then using what you determine to be the value of that variable and then plugging it in. Okay, so I'm going to go ahead and write up the same pair of information that we did for example 2, only I'm going to solve it in this method. Here we go. We've got x minus 2y equals 5. And we have 4 times x plus 3y equals 9. Now, if I maneuver this equation by adding 2y, I have x is equal to 5 plus 2y. Okay? That being said, I can plug x is equal to 5 plus 2y into the value of x, giving me 4 times the value of x, substituted what we found to be the value of x into x's location, and fill in the rest of the equation, distribute and solve. 20 plus 8y plus 3y. Combine like terms. Subtract your 20. Divide by 11. Look familiar? Exactly the same answer we had before. Let's verify that this worked. Plug in up here. X plus 2 is 5. You're still going to come up with a 3, aren't you? Same exact can of worms. The result is the same. Okay? You could have plugged this in here as well. And I'll go ahead and show that to you. Plugging it in here because the other time I did it in the other equation. So let's just say I want to do it here. 4x, 3 times negative 1 is a negative 3. Add 3. Divide by 4. How's that? Huh? Pretty awesome. That's the end of the first part of this video. I'm going to start example 3 in the next video.